So over the next two lectures, we'll look at reasoning, how we use evidence to make decisions, and whether we are, as humans, good at this. And there are basically two forms of reasoning that we can use to make decisions. One is known as inductive reasoning. That's what we're going to talk about today. And the idea here is that we are coming to some sort of probabilistic conclusion based on specific observations. So probabilistic, and you may remember this from the perception lectures, this implies that our conclusion is necessarily not certain. It's only true to some degree of certainty, so to some probability. Next lecture, we'll talk about deductive reasoning, and deductive reasoning is based on the rules of logic, and it allows us to draw certain conclusions. So inductive arguments can either be strong or weak, and it really depends on the nature of the evidence we have and how we use that evidence to come to a conclusion. So here's a weak inductive argument. So you might observe that all stores in Wolfville are open until 10 p.m. And then you visit Halifax and you find that stores in Halifax are also open until 10 p.m. And based on these observations, you conclude that all stores everywhere are open until 10 p.m. So one issue here, right, is that you're drawing a very broad and sweeping conclusion based on evidence that's limited, in this case, geographically limited. So just because stores in Wolfville and in Halifax, and maybe in other parts of Nova Scotia, are open until 10 p.m., this doesn't mean that stores across Canada and the world are also open until 10 p.m. Here's a stronger inductive argument. So ever since I can remember, the sun has risen in Wolfville every day, and the same is true in other places I visited. The sun will rise in Wolfville tomorrow. So this argument is stronger because your conclusion is limited, right? You're limiting your conclusion to Wolfville, where most of your observations come from. And it's also stronger because it's just based on more evidence, right? It's based on, an entire life's worth of evidence in this case. And evidence from outside your local geographical area. So the idea here is that the strength of an inductive argument really depends on the data, on the observations, and on the way you use that data to come to some conclusion. So the more specific your conclusion, the more likely it is to be correct. So strong inductive arguments result in conclusions that are more likely to be true. So you may be thinking, I don't think like this. I don't use induction when I make decisions. And that's not true, right? So if, for instance, you leave your house this morning or your dorm and you look up at the sky and you see clouds and you decide to go back inside and get an umbrella, you're using inductive reasoning, right? You're making a decision based on some observation. You're surmising that there's a high probability of rain occurring later in the day because you've observed, dark clouds. Now, we don't always think super deeply about decisions that we come to via induction. Sometimes we make snap inductive judgments. And when we do this, we're relying on a rule or a heuristic. So, when you sat down at your desk today to watch this lecture, or sat down, on the sofa, you made a decision that the thing you were sitting on would support your weight. It wouldn't collapse. And this decision is made via a heuristic that you have that chairs, sofas, benches are designed to be sat upon. And so we can use heuristics like this to speed up the process of making decisions via induction. Now, one form of heuristic that we sometimes use and can lead us astray is known as the availability heuristic. So we judge events as more probable if they're easily remembered. So if we have some observation in our memory that we can quickly draw upon, this may bias our thinking, may bias our decision-making towards thinking that, a particular event is more likely to happen, right? So if you sit on a chair and it, collapses under you, the next time you go to sit down, you might be a bit wary about doing that. Even though you know that, based on all of your past experience, it's very unlikely that, chairs collapse when you sit on them. So heuristics can work well at times. They can speed up the process of coming to a decision, but they can also lead us astray, right? So, a heuristic is a good way to decide that, maybe you should grab a rain jacket or an umbrella before leaving your house because the clouds are dark, and dark clouds typically mean rain. But of course, the cost, to making that decision is very low. So if it doesn't rain, what does it mean? It just means you're carrying around an umbrella for the rest of the day, not a big deal. Sometimes the availability heuristic can lead us astray, right? So if, for instance, you base a decision to fly on an airplane upon recent news reports of airplane crashes, you're probably not going to fly on an airplane. And you're making this decision despite, all of the evidence suggesting that air travel is actually remarkably safe. Much safer, in fact, than driving a car. So we have to be careful here that our decisions aren't too heavily biased towards available information, right? Because that available information can lead us astray and can cause us to make, a decision that is incorrect. Now, the availability heuristic and how it can sort of modify people's reasoning has been examined with relevance to the frequency of lethal events. Generally speaking, we're really bad at deciding whether a particular thing is dangerous or not. Right? So if I ask you, which cause of death do you think is more prevalent? Dying in a tornado or dying from an asthma attack? You'll probably say, dying in a tornado. And that's because every time, there's a crazy tornado and people die, it's reported in the news and you hear about it. But, the fact of the matter is you're 20 times more likely to die of an asthma attack than you are to die in a tornado. Drowning versus a car crash, you're much more likely to die drowning than you are driving your car. Pregnancy versus appendicitis, you're much more likely to die from appendicitis than you are, having a child. And again, what's happening here, the reason why you think that car crashes are more deadly than drowning, tornadoes are more deadly than asthma attacks, is because you probably have some sort of experience that you are drawing upon, typically from mass media, right? Tornadoes are reported in the news, car crashes are reported in the news, and this is sort of biasing your decision-making process towards this readily available piece of information. In this 1978 study, they simply asked people to rate how deadly they thought certain, environmental accidents and illnesses are. And generally speaking, we're pretty bad at doing this, right? So on this plot, we see judgments from participants in this study. And on the x-axis, we have their true frequency. And generally speaking, we tend to underestimate, right, the likelihood that we'll die from heart disease, stroke, cancer, diabetes, and overestimate the likelihood that we'll die from, tornadoes and floods, things that are reported in the news media. In this particular study, botulism, which is something I don't think of as being particularly dangerous, was reported as being quite dangerous, even though it's not. And that's because there was a recent botulism outbreak that was reported in the news at the time. So we have to be careful when we are making inductive decisions that our decisions aren't too biased by readily available information. The availability heuristic can lead to what's known as illusory correlations. So this is where you have some sort of experience and it leads to a false correlation, a correlation that actually isn't a real correlation, right? So you might go to Halifax and somebody is rude to you and you decide that people who live in cities are rude. So you've made up a relationship, you've made up a correlation that actually doesn't exist. And this can lead to stereotyping. So oversimplifications, generalizations about a group or class of people that aren't true, are based on one or a few examples that are taken out of context. So another heuristic that we commonly use to make decisions is known as the representative heuristic. And again, heuristic simply means some rule that we're doing to speed up this process of coming to a decision or coming to a judgment through induction, through observation. And so in the representative heuristic, we're making a judgment based on how much one event or thing resembles something else, some idea that we have in our mind of how things work, how the world works. So imagine that we randomly pick one male from the US population. His name is Robert, he wears glasses, he speaks quietly, and he reads a lot. If I then said to you, is Robert more likely to be a librarian or a farmer, you would probably go with librarian. Is that a good decision to come to? And the answer is no, it's not. There are way more male farmers in the US, 20 times more, than there are male librarians. So why did you make that decision? Well, you made that decision because Robert fits the description that you have in your mind, fits the representation of what librarians are like, right? They wear glasses, they like to read. And we can be biased by these internal representations even if we know the underlying statistics of the makeup of the population. Even if we know the base rate, we can still ignore it. So if I told you there are 100 people in a room, 70 are lawyers and 30 are engineers, and I said, what's the chance that if we pick someone from this group at random, they are a lawyer? Obviously you would say, 70%. So easy. But then if I said, Jack is a 45-year-old male, he's conservative, he shows no interest in politics or social issues, his hobbies include carpentry and puzzles, what's the likelihood that if we pick this person from this group, he's a lawyer or an engineer? You would probably say he's an engineer, and that's because, again, the description of Jack fits this internal representation of what you have about, who engineers are, what they're like. Generally speaking, we have to be careful because representative heuristics can actually lead us astray. And they can also cause us to ignore what's called the conjunction rule. And the conjunction rule is simply a rule of probability. It says the probability of two events occurring, A and B, cannot be higher than the probability of A or B occurring. So for instance, within the population of bank tellers in the US, a subset of those bank tellers will be feminists. So it's impossible that if you pick somebody at random from the US population, it's impossible that they're more likely to be a feminist bank teller than they are to just be a bank teller, right? This is the conjunction rule at play. But because of over-reliance on representative heuristics, we often ignore the conjunction rule, and this leads to an error in reasoning. So if I said, Linda is 31, outspoken and bright, she is deeply concerned with issues of discrimination and social justice, and then I said, which is more probable? Linda is a bank teller, or 2, Linda is a bank teller and a feminist. Some people would pick 2, so they're violating the conjunction rule here, even though it's much more likely that she's a bank teller, just a bank teller, as opposed to a bank teller and a feminist. So over-reliance on representative heuristics can lead to violations of this conjunction rule. So the takeaway, right, is that heuristics are a good way to speed up inductive decisions, but we want to make sure that we don't, rely too heavily on available information. So that's the availability heuristic, and on internal representations or ideas we have about how the world works. That's the representative heuristic. Another issue that comes up when we're making decisions, making judgments, is known as my-side bias. So when coming to a decision based on induction, based on observations, we often evaluate evidence in a way that is biased towards our own attitudes and opinions. So in this 1979 study, they gave proponents and opponents of capital punishment, so capital punishment means the death penalty, contradictory studies on its deterrent effects. So what does that mean? We have a group of people who support the death penalty, a group of people who oppose the death penalty, and we give them a bunch of mixed information. So some of the studies say that the death penalty is good at deterring crime. Others say that it doesn't deter crime at all. And so you would expect, right, that if you have all this sort of different information, that your opinion would become more moderated, right? You'd move more towards the center. The groups would become closer together. Actually, we see the opposite. So people who think that the death penalty is helpful, think that it's a deterrent to crime, believe the studies that support their view and ignore the other evidence. And the people who oppose the death penalty, think that it isn't a deterrent to crime, believe the studies that support their view and ignore the other evidence. And so this is an example of what we call my-side bias. Generally speaking, when you're coming to some sort of decision through induction, by looking at evidence, you want to look for evidence that actually disproves your belief. That's the basis of the scientific method, right? We're looking to disprove our hypotheses. And we often fall victim to something known as confirmation bias. So the idea here is that we're looking for evidence that only confirms our belief instead of looking for evidence that refutes our belief. Confirmation bias is pretty easy to observe in pseudoscientific ideas. So one pseudoscientific idea is the notion that humans, aren't causing global warming. And so if you believe that, you may, look for the 2 or 3 studies that support your opinion and ignore the thousands of other studies that have shown that, in fact, yes, humans are causing global warming. So if you ever have a strongly held belief and somebody challenges you on that belief, it's important to think about not just why you have that belief, but what would make you change your mind. And then you want to look for that evidence. Now, Peter Wasson, cognitive psychologist at University College London in the 1960s, was sort of the first person to study confirmation bias, mistakes that we sort of fall prey to during inductive reasoning. And he did this using a task known as the 2-4-6 task. He invented this paradigm. And so the idea here is that Wasson gives you three numbers, 2, 4, 6, and you have to figure out the rule that governs, how these numbers are grouped together, or the pattern. So the instruction here is you will be given three numbers which conform to a simple rule. Your aim is to discover this rule by writing down sets of three numbers. After you've written down each set, I shall tell you whether your numbers conform to the rule or not. Your aim is to discover the rule itself. When you feel highly confident that you've discovered it, and not before, you are to tell me what it is. So again, you're given three numbers, 2, 4, 6, and these numbers conform to some simple rule. And you have to figure out what that rule is by writing down your own sets of numbers. And Wasson will tell you whether your numbers conform to the rule or not. So the most common initial hypothesis was increasing intervals of 2. 2 plus 2 is 4. 4 plus 2 is 6. And so you might think, okay, 8, 10, 12. I'll write that down. And Wasson would say, yeah, that conforms to the rule, but that doesn't allow you to discover the rule itself. To discover the rule itself, you actually want to write down sequences that try to falsify your belief. So if your belief is that the rule is increasing intervals of 2, you want to write down sequences that actually involve some other pattern, some other rule. And the actual rule here is three numbers in increasing orders of magnitude. An order of magnitude means some sort of exponential change. So if you'd written down 10, 100, 1,000, Wasson would have said, yeah, that's right. That conforms to the rule. And so that would falsify your belief that the actual rule is increasing intervals of 2, and you'd have to come up with a new hypothesis. And so what Wasson found was that people rarely did this. People most commonly only wrote down numbers that aimed to confirm their belief, instead of writing down numbers that aim to overturn their belief, make them reevaluate their hypothesis. And this is confirmation bias. And again, if you have some belief that you feel very strongly about, think to yourself, what evidence would I have to see for me to reevaluate this belief, and look for that evidence. So we come to the lecture review. What is inductive reasoning? Question 1, what is inductive reasoning? The process of drawing probabilistic conclusions based on specific observations. Question 2, what's the availability heuristic? Question 2, what's the availability heuristic? Events are judged as more probable if they're more easily remembered. And the availability heuristic can lead us astray, right? So we want to make sure that when we come to some conclusion through induction, we're thinking of not just the most available information, but sort of the history of observations that could inform our decision. Question 3, what's confirmation bias? Question 3, what's confirmation bias? When people look for evidence that confirms their belief rather than evidence that refutes their belief. And this was famously studied using Wasson's 2-4-6 task.